Hi, and welcome to Section 4, Redux Data Flow. In this section, we're going to look at the concepts behind Redux and how it integrates with what we've discussed in the previous section with React and React Router. We're going to explore enough of Redux in this section to build a universal JavaScript application in the next section. For now, we'll be touching on the basics of Redux. Now we move on to the first video of this section that introduces the basics of Redux, looking at actions, reducers, and stores. In this video, we're going to take a look at state management in a modern single-page application, discuss the basic flows in Redux, and look at actions, reducers, and states in Redux. We'll round off the video with a discussion on async flows and action creators and middleware. In the last section, we discussed how React allows us to think of UIs as simple state machines. React lets us describe the UI as a function of state. In React, we simply update a component's properties to render a new UI based on the new state. React takes care of updating the DOM in the most efficient way. Take, for example, an e-commerce website, which has a searchable product catalog and a way to add products to a virtual cart for purchase. Within this site, you have many kinds of state: the state of the search, the filter sort state, the pagination state. There's also the state of the cart, the items that have been placed in the cart, and their subtotal amount. When combined together, these states form a unified view of what the user is currently seeing in the UI. In a sense, what the user is seeing and interacting with is a consolidation of states. When a user clicks on an action like Add to Cart, the product is added to the customer's cart. This updates the state of the button that was clicked, as well as the state of the cart. State machines are a mathematical concept that define a number of states that an application can be in. A state machine also must define a series of transitions between one state and another, and the triggering conditions for each of them. Single-page applications behave similar to state machines, where the state in the browser transitions from one state to another as the user interacts with the page. In other words, the actions taken in the UI cause a transition from the old state to a new state. However, as an application grows, it becomes harder to determine the overall state of the application and cumbersome to understand where the updates are coming from. This is where Redux comes in. Redux simplifies the way we view the state of our application by requiring us to store all the state data in a single object. Everything we need to know about the application is in one place. But how does Redux achieve that? Redux makes state mutations predictable by imposing a certain restriction on how and when updates can happen. Redux features a unidirectional data flow similar to React and enforces a single store where the state of the whole application is stored and is immutable. The only way to change the state is to dispatch an action, which is a plain object describing what happened. Actions dispatch reducers that perform state updates. Reducers are pure functions, which are given the current state, and the action return a new state. Let's see how actions, reducers, and state work. The Redux flow looks like this, where the view could be a React application. A user takes some action in the UI, and an action is dispatched. The root reducer function is then called with the current state and the dispatched action. That root reducer may delegate the work to other smaller reducer functions. It then returns a new state. The store notifies subscribers by running their callback functions. Subscribers, usually UI components, can retrieve the updated state and re-render. Let's look at each part of this flow in more depth. Let's start with the actions. Redux enforces that every change is described as an action. Actions are payloads of information that send data from the application to the store. They are the only source of information for the store. Actions are plain JavaScript objects with a type property that indicates the kind of action being performed. In this case, we are executing the add to cart action. Other than the type attribute, the structure of an action object is really up to the app. In this example, the action is passed the ID of the product that is to be added to the cart. The reducer specifies how the application state changes in response to the action. A reducer is a pure function that takes the previous state and an action and returns the next state. Given the same arguments, a reducer should calculate the same next state and return it, which means reducers should not have any side effects like mutating arguments, performing API calls. They're just pure calculations. In the simplified add to cart example, the reducer adds the product ID to the current cart state. Notice that we use the object spread operator that we introduced in the last section to help create copies of our current state with the updated values. The store in Redux is the object that brings actions and reducers together. The store is what holds the application state data and handles all state updates. The store handles state updates by passing the current state and action through a single reducer. The only way to change the state is by dispatching actions through the store. The store has a dispatch method that takes actions as an argument. When an action is dispatched through the store, the action is sent through the reducers and the state is updated. This is the basic flow of Redux. However, this is not how a true application would work, since the state in the browser is only a local copy that needs to update and reflect the state of the backend system. For example, if the user closes their browser or uses a different browser, the cart should be persisted. The browser's store, in a sense, is only a unified copy of the distributed data services. In order to make API calls to update the services, we need to introduce asynchronous calls in a fully synchronous flow. The Redux flow is completely synchronous by default. Dispatching an action does not return until after the reducer function has run and the new state is available. In order to achieve asynchronous behavior in Redux, we have to introduce two new constructs, an action creator and middleware. An action creator encapsulates the process of creating an action object. Action creators abstract away the details of how an action is created and is also where we can put any logic for communicating with backend APIs. Redux allows adding a middleware which listens to the actions and calls an API when the appropriate action type is received. It provides the ability to do asynchronous work related to the store. By using this specific middleware, an action creator can return a function instead of an action object. Here's an example of an asynchronous action creator. Unlike other synchronous actions we saw earlier, the action creator here creates not an object but a function. The function will get executed by the specific middleware called Redux Thunk, which is a third-party extension point that can be added to Redux. This action function doesn't need to be pure and can itself also dispatch actions. In this example, we fetch data from an API, and once successful, we dispatch another success action type with the response. Now that we've discussed action creators and middleware, we can revisit the data flow in the UI and action creators to be invoked. In this case, the function is returned by the action creator and is dispatched to the store. Middleware can inspect actions and state, modify actions, dispatch other actions, stop actions from reaching the reducers, and much more. In this example, we are using React Thunk, which knows how to turn asynchronous actions into actions. If you're wondering, a thunk is simply a function that wraps an expression to delay its evaluation. The function returned by the action creator runs and calls an API and updates the Redux state to be request started. The request started action could be used to indicate that the data is loading, and the view could display a loading indicator. Once a response is returned from the API call, we can dispatch a success or error action accordingly. Here we dispatch the request succeeded action that would cause the UI to update. Async action creators are especially convenient for server rendering and hydrating the state from the server in universal apps. We'll be discussing server-side data fetching in the next section. For now, we are ready to plug the Redux flow into our React view.